Hello, everyone, and welcome to podcast number 47. Find all of the intercepts. Well, for that, there's x-intercepts and there's also y-intercepts. So there's two things to do for the intercepts. Also, for the asymptotes, well, there's vertical asymptotes and there's horizontal asymptotes. So we've actually got four things to do. So if you want to put on pause and go get a snack, this one's going to take a little bit of work. Okay, so for the x-intercept, that means you put y equal to 0. So basically we're saying this is y and set it equal to 0. So that means 0 equals x squared minus 4x minus 8 over 3x minus 4. So when does the function equal 0? Well, the good news is the only way that a fraction equals 0 is if the top equals 0. So you could just have the top equals 0. And we could always do the quadratic formula, but I'm wondering it might be faster if we factor. So let me try to factor. If factoring doesn't work, we can always use the quadratic formula. So I need two x's, so x times x is x squared, and then I need two numbers that multiply to be an 8. Well, that would be a 2 and a 4. But if you subtract a 2 and a 4, that would give us a 2x in the middle. I don't think factoring is going to work. So go to the quadratic formula. It always works. So it's going to go negative the b plus or minus the square root. The b gets squared minus 4 times a, which is 1, and c, which is negative 8. And the whole thing is divided by 2 times a. So what's inside the square root? Negative 4 squared is a positive 16, and then a negative times negative is positive, and 4 times 8 is 32. So inside the square root, that is a 48. Now, if it would have been, for example, a 49, since you can take the square root of 49, that means that we would have been able to factor it. Since we cannot take the square root of 48 and just get a nice simple answer, that means, yep, we did have to use the quadratic formula. So then I get x equals 4 plus or minus the square root of 48 is divided by 2. And then this should be simplified because 48 is 16 times 3. So inside the square root is a 16 times 3. And the square root of 16 is 4. The square root of 3 can't be simplified, so it just stays there. And then finally, you can divide by 2, and divide by 2. Since I can divide by 2 in all three places, that's how it gets reduced. So that's going to be, as soon as I can get this black pen to work, x equals 2 plus or minus 2 square root of 3. All right, that is the x-intercept. That one's done. Next, for the y-intercept. So for the y-intercept, that means x equals 0. So for the y-intercept, you put x equal to 0. So that means that I just need to substitute 0 into the function. So put a 0 right here, and right here. So this is going to be 0, this is going to be 0, this is going to be 0. And so it leaves us a negative 8 over a negative 4. So this would be 0 squared minus 4 times 0 minus an 8. And then 3 times 0 minus 4. And of course all of these are zeros, so they're gone. And then negative 8 divided by negative 4 is a positive 2. That was pretty fast. Good news. All right. Then we're done with this. Next, the vertical asymptote. So let me just clean up this function. So the vertical asymptote means when does the bottom equal 0? So when does 3x minus 4 equal 0? So for the vertical asymptote, when does the bottom equal 0? So when does 3x minus 4 equal 0? So for that, we could just add 4 to both sides. It's going to leave 3x equals a positive 4. And then divide both sides by 3, and it's going to be x equals 4/3. Okay, so this is actually starting to speed up. That's good news. So we're done with this one, this one. The last is the horizontal asymptote. And for the horizontal asymptote, you can basically just say, you look at the numerator, minus 8 doesn't count for that much, minus 4x doesn't count for that much. The leading term, or the most powerful term, is x squared. On the bottom, the minus 4 doesn't count for that much. So that means we basically just have x squared divided by 3x. So for the horizontal asymptote, so it's basically y could be approximated by the top, the most powerful term was x squared, the bottom, it was 3x. And when you reduce and cancel an x and one of the x's, it leaves x divided by 3. And if x is going to infinity, infinity divided by 3 is so big that it still equals infinity. And there are all the parts.